Hello everyone, this is Salar Khan and I am live with another video to talk about what are functions in Python and what do they really do, when do we use them, how do we use them, and what purpose do they really solve. So I'm going to need an example to demonstrate functions and I'm actually going to construct one with you. So let's play through this example with me. I'm going to start with a comment where I'm going to ask you to think of a number, and based on whatever you think, I'm just going to think a number here, and then I'm going to ask you to uh, double it, and in my case I am going to basically be implementing this is how I would double it. And what I would do next is ask you to add um, say 8 to the result, and you could do it in your head, but for me I would just simply use some mathematics to add 8 to it. Alright, and the next instruction for you would be to uh, divide it in half, and let's just use another variable, and this is how I would divide it, right? And then I would say subtract originally thought number, and in my case the originally thought number is x. I don't know whatever you thought, but I would subtract x from it, and then I would simply go ahead and tell you that the result you currently have is 4, and I'm going to print q, which is my most updated variable, and the answer would be 4 for the number I thought and also for the number you thought. Okay, but I don't know what you thought, and is why are we going to have the same result as number 4? That is for another time to, or another video to see the mathematics behind these 4 operations. But we will get the same number. Now to demonstrate it, I could use a different number. For example, I could use 20 instead of x and I would still get 4. I could use 30 instead of x, I could still get 4. Now the result that I achieved with 10 and 20, they're gone. They're not right there. So to obtain them again, I would go with 10 again. But to show that yes, I do get them for different numbers, I might have to copy my code and paste it in another cell, and write 20 and get an answer for 20, and paste this in another cell for 30 to show you that yes, indeed, I get the same answer for 10, for 20, and for 30. Now imagine if I had to do this 100 times. I would not want to keep a record of each number that I used and these bunch of 5-6 lines of code again and again, right? This is why we need functions. We don't want to repeat the same block of code or the same black box again and again, and we could in fact use one simple operation of calling that function, of calling that specific block of code with our new inputs and obtain our new outputs. So that is why we use functions. Let's see how we can functionalize this particular code and do it, and in fact generalize it. This is what functions really do. They generalize a bunch of operations in one standard way, and then we could use that generalization in a nice manner. So let's go ahead and try and do this very simple example. So I could use this specific code and think through different numbers and see my outputs for a bunch of numbers for many different times. Okay, the way we could define a function is literally use the def command, which is the definition of the function. We literally want to define a function now, and the function would require a name. So I'm going to call this as a number game function. Right, so I'm going to call it a number game function. Then I'm going to put in some round brackets to specify what is going to be the input to this function. So I'm going to say originally thought number. So let's just call it originally thought number. Okay, so this is the input number that you originally think through, right? X in our case. So this is what we think. Whatever we think, we could feed it as an input to the function called number game function, and it should give us some sort of an output. Syntax requires me to put in a colon at the end of this, and as I press enter, notice it automatically brings in these this indentation. See, there's a couple of spaces, a tab essentially, which tells me that the function definition really goes in here. It cannot start right away from the beginning of the line. It starts after some indent. Okay, and whatever is in the indentation now is actually going to be the definition of this function. Whatever code it comes in is actually going to be part of this function. So what is our code really? This is our code. It's the same thing that we keep repeating again and again. This is what we want to repeat, right? And I'm going to make it a part of my function. So all of this is now part of the function. And one critical observation here is that I do not want x to be the input. I want the originally thought number, this specific variable, to be my input and be used throughout these calculations. So I'm going to say my x is equal to originally thought number, and that number, whatever that may be, is actually going to get doubled. 8 will be added to that result, and then that result will divide in half, and then that result will sequentially get subtracted by my originally thought number x, and that's going to get stored in Q. We're going to print Q. Now, let's not print the number in the function. Let's leave it as it is. We can always print it outside, but we do want a return value, right? We do want to return the output Q. So one of the things we could do is we could simply use the return value, return specific return command to return any variable that we want from the function. We could use any variable, but in our case it makes sense to return the final value, the final output, and we could use this as our return value. What that does is and this is our function as it is. This is what we have defined as a function. We could in fact go ahead and run this cell, command shift or control shift to run this cell, and it has run through, right? So once we have our function all defined and all set, what we could do next is simply call this function. And the way to call this function is to just use its name, which is quite intuitive, number game function as it is, and then we have to specify some input. So what is the value that originally thought number that can take? So let's try it for 10 that we did initially, right, in the earlier example. And this is supposed to give me an answer. When you feed in 10, it goes through these operations and it gives you an answer Q. And as such, if I print this, it should give me, if I print this, it should give me the answer, the value of Q that I'm supposed to get, right? So I can go ahead and run this cell and it gives me the value 4. That's perfectly fine. Now, what I could do is, I could also, instead of printing it, I could also store this. I could also store this, the outcome of this. I'm going to change it to 8 in another variable. Results from. I'm just going to call this variable as a results from function, and I could store this in a variable and then print this variable. So that's also something I could simply manage, right? And if I do it, I still get 4. That's the mechanism of, that's the game, that's the mathematical operations, that part of the functions. But notice, for different numbers, for 10, for 8, I do not have to type in or copy paste all of these operations, because I'm using them from one common black box, one common function that I defined for once. I just have to define it once, run the cell, and the compiler knows that number game function, this is the definition for number game function, is going to run these operations on whatever input I feed in this function. So now my life is simple. Now I could simply just keep calling this function, print the output, and do it for different values, right? So I could just call this function many times for many different numbers, and simply see what does it give me. And it gives me 4 each time. That's the nature of the mathematical operations that we have, but we can call the same function on many different numbers to obtain our result. So that's the beauty of functions. They let you do same things, repetitive things, without having to write their operations individually, without having to copy that code individually many different times. And you could simply just reuse one function again and again with different inputs, and it takes those different inputs, processes them through one mechanism, and gives you a return value, which is a different return value each time. It just so happens that we get the same one for this particular mathematical phenomena, where you simply get the same answer each time, irrespective of what number you feed in. But you could call the same block of code for different inputs. This is what functions are meant for. Thank you.